Hello and welcome everyone to one of another exciting series of the tinyML talks. And today we have a very special session talking, another exciting talk as part of enabling ultra low power machine learning at the edge. And we have the pleasure to welcome Carlos Rodriguez and Brad Rex from Renesas, who will talk to us about what the work they're doing and all the amazing stuff that they have for enabling a low-cost, low-power, reliable, and accurate solution with Renesas. Thank to our tinyML strategic partners for their commitment to taking tinyML to the next level altogether. Analog devices, ion devices, ARM, Deep Light, Edge Impulse, EMSA, PhotoHub, Green Waves, Gravity Inc., IBM, Imagine Mob, Itimit, Clicatech, Microsoft, Nota AI, NXP, OctoML, Prophecy, Hixo, Qualcomm, Reality AI, Rexan Technology, Renesas, SAP, Seed, SensiML, Silicon Labs, Sony Semiconductor Solutions Corporation, Stream Analyze, Synaptics, Synsense, Sentient, and TDK. Thank you so much for all your support. And also, we would like to announce the next tinyML talk that will be, as part of the Neuromorphic Engineering Forum. This will be chaired by Professor Charlotte Frankel from TU Delft. And this will be a virtual event on September 27th. I hope you don't miss this great opportunity to learn more about what's happening as part of this fast-growing initiative of tinyML around low-power machine learning technologies for edge devices. And if you're interested in sponsoring this event, please let us know. The link is available here. You can easily also register for the event by using the image here or going directly on the website using this URL. I hope you can join this great forum. And we also have the Tiny EMA Innovation Forum, which is also another exciting event that happens in the EMEA region. So this is a conference that's going to happen in a hybrid, in person actually, in Cyprus, in the Grand Resort. And the URL is again here. Registration is also open. I would like to remind everyone who's interested in attending the event that the late fee will happen after September 15. So please take advantage of the early registration discounts. We also are featuring really great keynote speakers as part of this event. And again, if you're interested in sponsoring this event, please contact us through this email address. Again, you can register by going to the website or using this barcode. And also another reminder around, the tinyML Smart Weather Station Challenge that is happening. So there will be office hours on 23rd of September. And the time, this is also a virtual event. And this is part of the AI for Good tinyML Challenge. So again, I hope you can join these initiatives. They're really great in terms of keeping the ball running for all the great tinyML initiatives and also providing more education, enablement, and collaborations across our community. Please join the tinyML communities if you haven't joined. This is a fast-growing community. We're already at 11,000 members across 46 groups in 37 countries. I also hope you can join the community in LinkedIn. We already are 3,000 members and more than 8K followers. This is the way, to stay connected and up to date with what's happening in this exciting area and also connect with like-minded people. I hope you can join us. And also all the talks are all available and all the exciting events that tinyML is organizing, including the one that we have today, are available in our YouTube channel. So please subscribe so you can get the latest updates and notifications and stay up to date. On to today's talk. I'm very excited to introduce Carlos Rodriguez. Carlos has over 5 years of experience in different business development roles within the microcontroller industry. He's targeting a variety of markets like industrial, healthcare, consumer, and payment. His education comes from the University of Texas at Dallas, where he obtained a bachelor's in electrical engineering and a double master's, MS in electrical engineering, and also an MBA. Thank you so much, Carlos, for joining us today. Also, it's my pleasure to introduce Brad Rex, our second speaker, who has over 20 years of experience in embedded design and development, covering both hardware and software. He started with ASIC design and verification, and later on, he moved on to directly supporting customer software development as both an application and field applications engineer. And he successfully got a wide variety of customers ranging from consumer, industrial, automotive into the production real. And Brad has an electrical engineering degree from the University of Arizona. So thank you so much, Brad and Rodriguez, and a big welcome to today's tinyML webcast. So I'll pass it to Carlos and Brad to tell us about the exciting work that they're doing in the space. Thank you.
Thank you, Qatar. Appreciate it. So again, my name is Carlos. Thanks for the introduction there. So today we're going to be talking about helping you guys through the Smart Station Challenge that you guys are working on. We want to help you get to a low cost, low power, reliable, and accurate solution with our products. So feel free to ask questions throughout the call through the Q&A, and Qatar's gonna let me know as you guys are asking those questions. I want to answer them as I go so that we can have a little bit more of an interactive meeting here or call. So here's the agenda for today. This thing works. There we go. So first I'm going to start with kind of giving you guys an intro again, just so that we can sync up on what the challenge is and what are some of the requirements. Hopefully you guys already know that, but we'll kind of review that. I'll introduce you guys to our RA2E2 low power microcontroller, as well as our fast prototyping board that comes along with that microcontroller. Brad will then show you our Quick Connect platform, which is basically a platform that allows us to connect sensors very easily. We'll introduce two of our sensors that we think you guys could potentially use for this challenge, the HS3001 and the FS3000. So we'll talk more about those. Then we'll actually show you how to connect our fast prototyping board with those sensors. And, the point here is to show you how easy it is to actually demo it. And, we'll do it within 10 minutes or so. And then I'll kind of talk about a little bit of the potential solutions of how you guys could put together, this kind of smart weather station. And then we'll kind of end up with a Q&A. All right, so again, the intro here is the goal of this challenge is to create, like I mentioned, low cost, low power, reliable, accurate solution that it's easy to install and maintain as well this weather station. And one of the things that we're requiring in this challenge is to not be any mechanical moving parts in order for, I guess, going back to the reliability side of things, you don't want any moving parts because then, you could potentially, there's more risk of parts actually breaking. So let me jump into, that's the main thing that I wanted to kind of make sure we're all kind of on the same page on what we're, why we're showing you this products, because this is kind of our goal. So the first thing that I want to show you here is our RA2E2 low power microcontroller. So there's a few things that this microcontroller is going to be really good for this challenge. One of them is a very low cost part. We're talking about under $1 part and even in low volumes. So it's a small microcontroller. It runs at a 48 megahertz core. It does have a Cortex M23, which is basically one of the latest cores from ARM. It's a 32-bit, And it's going to have plenty of flash, which is 64 kilobytes for you guys to store models in there, AI models, as you guys are working on this project. We have 8 kilobytes of SRAM, 2 kilobytes of data flash. So, basically for the price, you get a lot, high speed, good memory size, and a bunch of other features and interfaces, like the ADC. That might be something that you might want to use as you're kind of plugging in sensor to this microcontroller. And it even has some kind of reliability features like your SRAM parity check, to allow you to make sure that the SRAM is not getting corrupted. It kind of allows you so that when data is written, a parity bit is actually added to every 8-bit of data in the SRAM, which, when data is actually read, the parity is checked just to make sure, the data is complete and it's not changed, and when a parity error does occur, we actually have the ability to provide that notification to the user. And, you can just kind of trigger a reset, or, you can kind of figure out what to do with that notification. The other thing here is the cyclic redundancy check that we have in this part, which generates a code to detect errors in the data as well. So kind of similar, going along with the reliability part of this project. The bit actually allows us to really kind of monitor, specific addresses and be able to detect, again, different types of, and this actually, rather than the NSRAM, you can actually check the kind of similar thing, but in the flash, so that, in case you have any type of issues within the flash and things got corrupted, you can still kind of get this notification and be able to act on it. So that's the reason why we're kind of introducing this part. It's actually one of our newer parts within our Renesas RA2 family of products, and we're really excited about it. I think this part will actually really help you guys as you guys are working through your project. This part also has other, like, many options, from, depending on how big your AI model is going to be, we do have different variants available, starting from 16 kilobytes of flash all the way to 64. And we also have different packages. If you're really trying to make your solution really small, you have things like our 16 pin WLCSP package, which is only a 1.87 millimeter by a 1.84 millimeter, which is super, super tiny. So that's an option. If you're really trying to make your solution small, we do have those packages available. Now, from a low power consumption side of things, this part is also very low power. Our RA2 is consuming in active mode about 81 microamps per megahertz. And if you compare it to some of the other players out there, we're kind of in the lower side. However, on the standby mode, I think that's where we really kind of excel at only 0.2 microamps in standby mode. So this is actually really good, I think, specifically for this project, because most of the time that you're going to be having your weather station, most likely, you're not going to be sensing data every second, right? It is more of maybe every minute, maybe every 10 minutes or so. So a lot of the time, your microcontroller will probably be asleep. And then you'll kind of wake up to kind of figure out the kind of what the sensors are bringing, what data they're bringing in, kind of doing the processing. If you have to run it through the AI model, and then you kind of put it back to sleep. So having that very low power standby consumption is going to be, I think, very, very helpful for you guys as you're trying to make this as low power as possible. The part does come with we do have a fast prototyping board. There's usually 2 different development boards that we kind of bring out with every RA family product. One of them is like the full EV kit that kind of exposes all the pins and everything. This one being a small microcontroller, the fast prototyping board in theory, it's a smaller board, but in reality, we're actually exposing pretty much everything. So let me just kind of go through the features of this board. We do have two PMOD interfaces, so you can connect the sensors. And again, we'll kind of talk about the sensors that we, in Renesas, we already have. And the platform, the Quick Connect platform that Brad is going to be talking about, but that's what those PMOD sensors are for. Or if you want to use external sensors, you know, if you've already decided on your sensors that you want to use, you know, PMOD interface is actually a very common interface that you can use. So it's going to be a very easy plug in, maybe write a little bit of code and you can get it up and running pretty easily. We also have the Arduino Uno R3 Connector. So in case there's like shields that you're kind of thinking about using, you can plug those on top of the board. It's already, you know, the board already comes with that, with those headers. So that's kind of neat. Another thing that is kind of nice about this board that you don't really have to work with an external debugger. There's actually an E2 emulator light here on the right side. Let me see. Let me do this. Laser pointer right here. So we have our debugger. So there's actually everything's on board. You don't need an external board to program the part. You know, all you really need is this fast prototyping board, and you can start programming the RA2E2 with, again, any models that you might want to create. This is actually a really cheap board. It goes for about $16. Actually, yeah, about $16. If from the Renesas website, if you go through the distributor, it might be a little bit more expensive. And it's only a 54 millimeter by 85 millimeter size board, so it's pretty tiny. At the same time, you know, if there's specific pins that you do need, we do expose those through the through holes here. You know, you can add headers on those so that you have access to basically every single pin that the microcontroller has access to. So let me see if there's anything else I'm missing here. I don't think so. So I'll kind of move on to the next slide. That's the microcontroller we're going to be suggesting for this project for those reasons. Again, we think that's going to allow you to have a low power solution, low cost solution. And I'll actually be talking about a giveaway that we're going to be doing at the end of the presentation. So stay tuned for that. Now I'll go ahead and pass it on to Brad so he can tell us a little bit more about the Quick Connect platform. So Brad, go ahead and take it away.
Sure. Great. Thanks, Carlos. So thank you, everybody. So I'm going to talk a little bit about how you can use kind of the RA2 and the fast prototyping board connected with some of the other sensors that we have, not only within the Renesas portfolio, but external sensors that may come from other suppliers or ones that have already been developed by other companies. Pull everything together so you can kind of make your solution for the smart weather station. So what Renesas did, we have what we call our Quick Connect platform or QC IoT. Effectively, this encompasses, you know, how do we enable customers like you to take hardware quickly and easily put it together, and then also quickly and easily add the software portion so that you have both a hardware and software solution. Super fast, made for prototyping. You know, once you peel back the first layer of the onion, kind of once you get the prototype done, you can see all the API calls. Everything is compliant. We take great pride in the software quality that we have within both our E2 Studio development environment, as well as the flexible software package, which is what the RA microcontroller runs on. It pulls everything together. So on the right-hand side here, you'll see all of our sensors that we have in our portfolio, whether it's temperature and humidity, flow sensors, we have some air quality, so indoor and outdoor gas sensors. We have some light sensors as well, time of flight, and some others. All of these basically are put onto PMOD boards. You know, the PMOD is a standard from Vigilant. We standardized to their form factor to make it a little bit easier just to make sure the connections work correctly. But all of our sensors have this capability. And then also on the other side, as well as the fast prototyping board that Carlos ran through, nearly all of our digital microcontroller or microprocessor boards have PMOD connectors built on board. So you can take all of our sensors, easily connect them all together to make your solution. On the left-hand side, we're showing over here, kind of the software stack up that's already been developed as part of the flexible software package. This actual software actually encompasses more than just the FSP. So the flexible software package today is primarily used for our RA microcontrollers, but we have other software families for our RX family line, our RL78, even the Cortex M33s that we have in our higher end microprocessors like the RZ. And so we have basically software that encompasses all of that. However, for today's kind of discussion, we'll be focusing kind of on the flexible software package. All the software has all been created. So we basically have middleware components to control the sensors. We have demo example application code that's been built into our IDE. On top of that, we also have a developer assistance, which is what I'm going to use today to kind of demonstrate how easy it is to kind of pull everything together. The developer assistance allows you to effectively do drag and drop of software code to make it very easy to get started with. And again, once you kind of get started, show off what you wanted to do, you can then quickly and easily figure out what the code is doing and then make more modifications to that code to actually fit it to your particular application. There we go. I'm going to walk through kind of two of the sensors. These are some of our latest sensors that we just announced. Actually, the HS3001 or the 4000 family, I think, was just announced kind of in the summer time frame. This is our lineup of humidity and temperature sensors. This particular version, the 4001, this is a digital interfaced device. So basically it digitizes the temperature and humidity, sends it out over I2C. We have other variants in this family that also can do analog. So to Carlos's point, if you wanted to use the ADC or you wanted to have even higher precision with an external ADC, you can easily take some of our humidity and temperature sensors, run them through an external ADC, and get that data value you want. Very fast response times. The typical response time to get something out of our sensors is about 3 seconds. We have varying levels in the family in terms of the resolution and the accuracy. So the relative accuracy, plus or minus 1.5%. We have other devices that are a little bit higher than that, depending on, kind of the performance area you want to be in versus the cost that you're looking to be. Low power, very low standby power. So when you have your whole weather station kind of just hanging out, in between sensor readings, we'll be taking up a little bit less power, as well as the microcontroller. We also have a waterproof version of this, so it's IP67 rated. So if you have it in a kind of a wet environment, more often than not, we have one that's have a membrane that's been put on top so that it's hydrophobic. So this allows you to put it into kind of harsher climates than just kind of having it in indoors. Another sensor that we have is our flow sensor lines. The FS3000. This is an air velocity sensor module. Basically allows you to detect airflow across the device. Again, this is coming out of a digital interface, so it's an I2C interface. And as you can see here, we have basically kind of the ability to detect flow of air across this. We also have other ones that can detect gas and other types of airflow. But primarily for the smart weather station, this would be an applicable sensor just to get the wind speed as it's coming across kind of in the area that you have the smart weather station built. Okay, so what I'm going to do now, I'm going to, Carlos, if you can stop sharing and then I'll take over. What I'm going to actually do is show how our flexible software package and our E2 Studio works. Basically within about, kill some things here. Basically within probably about 5 to 10 minutes here, we're going to get the entire microcontroller up and running and actually reading the sensor data and actually outputting it. So again, just the whole purpose of Quick Connect is really just to help anybody in just quickly prototyping, bringing something together, and actually showcasing a proof of concept very quickly. What I'm showing here, this is our E2 Studio environment. This is our Eclipse-based IDE. This is what we use actually for most of our microcontrollers within Renesas. So before I get started on that, I'll just showcase, as I can see myself, fast prototyping board, about the size of a credit card. So very small form factor, as Carlos mentioned. two PMOD connectors. I have the HS3001 already connected to it. So this is the hardware, and we'll try to excite it in a little bit with a cup of coffee here that I have. So what I'm going to go ahead and do is let me just start. We'll just create a new project from scratch. So we'll create a new RA project. We have a lot of templates that have already been built into our E2 Studio environments. This makes it easy for us to determine, what's on these boards. As Carlos mentioned, there's many different variants with many different SRAM and code flash sizes. You need to obviously have those parameters inside your software package, otherwise it won't compile correctly. I will just make a quick project name. We're using the latest FSP. This is version 4.0. We'll pick a board. The board allows us to basically set up a lot of easy variables and environment variables for our project. So this will be the FPB RA2E2. As you can see, it already changed the devices. It knows exactly which device is on there. This will be GCC based, and then E2 Lite is the debugger that we have built on board, so it knows how to talk to it. For the purpose of this, I'm just going to go with something very simple. So non-RTOS, we're just going to do a bare metal application. We do support, I can show actually, we do support both Azure RTOS from Microsoft as well as free RTOS from Amazon AWS. Both are fully integrated and supported as part of our software offering for customers. We will go, you have two different projects. If you're looking just to make sure your hardware is working, we have a Blinky project, which will just blink the LEDs on the board. I'm going to go with just the minimal one so that we have less code, and we'll get that started. It's out of the way a little bit. Just a couple seconds here. It's basically pulling in all the software content that it needs. A lot of this is XML driven. You'll see that in a second here when it pops up. We have our XML based editor. You can see pin conflicts and graphically. So for instance, here on the right hand side, you'll see all the pins on this device and what they're actually connected to. And so you can quickly change these. We also have the ability to change clocks. So you can change clocking structures and clock trees if you want to slow the part down. We actually can also change the pins, which is what we're going to have to do here. By default, the pins for the PMOD are set for SPI, but we need to change them to I2C. So what I'm going to do here is let me get rid of some of these other panes to make it a little bit bigger. I'm going to disable the SPI port. So very quickly, I can just go in and disable the SPI port for this. Obviously, for you guys, if you're trying to understand a little bit more about this, you'll need the hardware schematics for the actual board itself. Schematics are available on our website, so you can easily download the schematics for that. We'll have some resources. If you have any questions, you can easily either go through the resources or through the Renesas website for that. So we'll disable the SPI and the SCI. This is our serial communication interface. This is our I2C multi-port channel. I'm going to enable this to do simple I2C. As you can see here, it automatically detects which pins are there. I happen to know because I've looked at the schematic that these are correct, so we'll have that all set up. Next, we'll create the stack. So as I mentioned before, the software is all built in. So we have sensors here. One thing I'll mention here, I'm actually on this board using the HS3000. This is our previous sensor board. The HS4000 is so new that I haven't gotten one yet. We've been trying to fill the channel and make sure that our customers can get them. They work exactly the same in terms of how they operate here. So just for illustrative purposes, I'll show the 3000 since that's what I have on with me today. All the software is all pulled in. You'll see here, it's basically, it'll highlight things in red which it thinks need attention or there will be errors. So it actually won't compile until you actually look at it. If you actually hover over it, it'll actually will tell you. So it says, okay, you need an I2C peripheral. So down below, this is telling us that we need to add something. So we'll add the SCI I2C channel. That'll be added in, still red, so it's still seeing some issues. What it's basically seeing here is that the channel that we have selected for the serial communications port is not set correctly. So it's a channel that doesn't exist. In this properties pane, we have all the properties for this particular module, so they can easily be graphically changed. And if we scroll down a little bit, let me pull this up a little bit. You'll see it's channel 0. There actually is no channel 0 on the RA2E2. If we go back to the pins tab, the channel actually was port 9, so it's SCI 9. So we'll go back to the stacks, click on this one, we'll change the channel to 9. And everything is happy. So it's all perfectly happy in terms of how it was created. What I'll go ahead and do now is I'm going to generate the project. So basically everything that we've graphically created here will be converted into C code. So I'm just going to always save here. We'll generate all the C code and pull in all the necessary files for the sensors into this project. I'm going to open up our entry C file. Right now this is empty, so we currently, the HAL entry is kind of our entry point into this our project. There's nothing here. I'm just going to add in a couple of lines here as we're going to start dragging and dropping some code. What you also see is the developer assistance. This is what I was talking about before. So we have a sensor module that has already been created, and we have, let me expand out some of these low-level modules that are in here. We have functions like quick setup, quickly getting the humidity and temperature. We can also quickly set up our I2C bus. All these can be dragged and dropped. So for instance, for the sensor, if we want to do a quick setup of the sensor, I'll drag and drop some code in here. All the code that it feels is required for us to start that sensor is all built in, and we have kind of our function call to kind of get that going quickly. So we'll need a quick setup for the sensor. One thing you'll also see in the comments here, it's very well documented. So we do run Doxygen in the background. So we have full documentation available in HTML format. But inside, we also basically tell you little hints, right? So for instance, for this one, before we can call quick setup, we have to set up the I2C bus. So GCOM's I2C bus 0 must be set up. That's this one, so we need to call this quick setup. So let me find some empty room here, and I'll also drag in this setup function. So now we have the quick setup for that. And then while I'm just dragging in code, later we're going to have to get the humidity and temperature reading. So there's another function call that's already been created for us to do that. Just for illustrative purposes, I'm going to create a couple of global variables for our temperature and humidity. So we'll make a couple here. This morning, okay. And so let's get started. So first thing we need to do, as it kind of alluded to in the function call here, we'll need to set up the I2C bus first. So let me get the function prototype for that, which is this. And we'll go down to our HAL entry. Get rid of this, and we will call that one. Then we'll also create the call the sensor quick setup. So this will allow us to set up the sensor and all the software below. By the way, most of the software is all POSIX socket style commands. So open, close, init, typical functions that you would see. Okay, so these two function calls will allow us to basically set up the I2C bus to make sure that we can communicate with the sensor, and then also to set up the sensor. You'll also notice standard for Eclipse. If you hover over function calls, you'll get kind of the prototype. You can also do F3, allow you to actually get to the function. What I'm also going to create here is just a while loop. So for us to just kind of hang out and read our sensor data. And that was the other function call that we had dropped in. So that was the, somewhere up here, this quick getting humidity and temperature. Now scroll back down. Okay, so one thing you'll notice here, I'm going to hover over this. You'll see that actually we require one parameter. This is just a structure for us to store the temperature and humidity data. So let me create a variable for that so that we can store it. So humidity and temperature data. And then I believe it should have been looking for a pointer. So we'll, by the way, control spacebar allows you to kind of pre-fill or try to kind of autocomplete code as you're going. These just going very quickly in here. So if we wanted to look in this data structure, so if we hit F3, It tells us basically we have two other structures built inside. One is for humidity and one is for temperature. We actually split out the humidity and temperature into kind of the integer portion and the decimal portion. I'm going to actually quickly just combine those so that it's one float value so that it looks more reasonable from a human level. By the way, the temperature is coming out as Celsius. So if you needed to do a conversion to Fahrenheit, you just have to run it through a standard formula to do that. So what we will do is for our global variables, so the temp, I'm going to just convert that. So it's going to be the temperature, the integer, and we're going to add the decimal point portion of it, temperature decimal, divided by 100 so that it is correctly aligned, and we'll do the same for the humidity. Okay. All right, so I think that's actually it. So again, all the function calls all built in. You'll see that out of this, I've basically written, 5 lines of code, a couple variables. We pulled in some quick setup functions, and then mostly just did some conversion just so that we can read the numbers a little bit easier. I didn't write all this code, and neither did I write all the low-level code that's already in there. To be honest, all the low-level code doesn't really add value to your project. Nothing for you to actually gain out of that. So a lot of that's all been created from the Renesas side. There is one thing that I did forget to do. We do need to enable some callback functions. So when we know that the I2C sensor reading is complete, that we know that it's done. So I'm going to enable those. So we'll have a non-blocking call, and we will enable the callback function, which is in here. And then just for the purpose of this particular class that we're in right now, the temperature sensor, I believe, it basically waits for 4 seconds. I'm going to actually speed this up a little bit just so we see it moving a little bit faster. So I'll basically read it every 100 milliseconds from there. Let's see, and I've got all the zoom control functionality at the top. So let me just, sorry, because I can't see it. So let me build the project really fast. Okay, so 0 errors, 0 warnings. Shocking. We'll go ahead and debug it. So let's program the device with this project. So we will launch into a new perspective, which is have a debug perspective so that you can see some debug values and variables. What I'm going to actually do is we have this expressions pane. I'm going to actually monitor the values for the temperature and the humidity. One thing we can also do with our variables, I'll right click, I'm going to enable real-time refresh. So it'll basically refresh the value of this variable in real time, even as you're running. You don't have to actually stop it and see the variable and what it changes. One thing I'll also mention is we do have other panes that you can add. We do have like charting, graphing. So if you wanted to graph temperature and humidity over time, you could also see that as well. All right, so let me run this. Let's see. I might have made a mistake here. So as is typical for running a live demo, let me go back and see if I missed something here. 1 second. I promise it all worked at one point. Let's see, 9, I squared C. Okay, got it. All right. Double check really quick here. let me rerun that really quick. If I can't get this working quickly, what I'll do is I'll debug it really quick while I'll pass it back to Carlos. But just give me 1 second. I'm just running into all kinds of issues now. It's just typical of normal debug process here. Let's try that one more time. Let's see. Now it's all.
Yeah, Brad, if you want me to kind of continue, I'll go through my last 2 slides while you kind of debug that, and then we'll go back to your stuff.
That'll work once I can. So let me stop sharing really quick, and then you can take over and I'll debug really fast.
Yep. Sounds good. Sounds good. Thanks. All right, let me share my screen again. All right, hopefully you guys can see my screen. Yep. Okay. So this is actually the giveaway that I was mentioning earlier. So we do want to help you guys, and we want to be able to support this project. So we're actually, as Renesas, we're signing up to give away up to 100 boards that are actually 100 gift cards, which is going to allow you to be able to buy the fast prototyping board for the RA2E2. And essentially the way it's going to work, as you guys make a submission with our microcontroller and our fast prototyping board, once you make the submission, we'll kind of provide that gift card to you guys. So hopefully this kind of provides a little bit of, incentive for you guys to start using this product. I think it really is a good product for you for this type of project. So feel free, if you make the submission, you will get that gift card. If you guys also need, if you guys use the sensors, we can also look into providing you maybe some money for that as well. So some extra gift cards that are going to cover for these sensors as well. But we can look into that once you guys make the submission. But for sure, the microcontroller will be covered. And the next slide that I have here is really probably some potential solutions. There's 2 options that I kind of thought about as I was kind of putting this presentation together. One option is to actually use the RA2E2 to run the AI models. We have actually created a lot of partnerships with different AI companies, a lot of them which are actually part of the tinyML Foundation, like Edge Impulse, Micro AI, SensiML, Imaginal Reality AI. It's actually now part of Renesas. So we've created a lot of demos together, and if you guys do want to use, if you guys are already maybe used to, let's say, the Reality AI tools, feel free to use those. We can kind of help you guys on loading those models into the RA2. So the first option would be to run the AI models on the RA2. The microcontroller would also manage the sensors and actually help kind of output those results, whether that's going to be via wireless, which I know that's not one of the hard requirements, but maybe eventually at second stage you would want to output those results via Wi-Fi or Bluetooth, whatever that is. And that's actually another thing that we do include as part of our Quick Connect platforms. We do have modules and PMOD boards with BLE capabilities, Wi-Fi capabilities, LTE capabilities. So, you could also use one of those PMOD connectors and use kind of the similar process of using the Quick Connect platform to go that extra step if that's what you guys want to do. So that's what I would do. And kind of the idea here would be on the humidity and temperature sensor, which is our HS3001. So you could actually use that to figure out if it's actually raining. I think you could actually create a model, an AI model, with these 2 sensors, with these 2 sensors data, the temperature and the humidity, to figure out if it's actually raining or not. You would have to create that model. You would have to, obtain some data in order to create that model. But I think that's doable, and that's for you guys to figure out. But that's one suggestion. And then you could actually, on the wind side of things, which is one of the other things we're trying to measure here in this smart station challenge, you could potentially use 4 different airflow sensors, one in kind of each direction. And, kind of use a little bit of math there to figure out the direction of where the wind is coming, and also the speed for that direction by kind of using this type of setup where you have one airflow sensor in each side of the board. So that's one option. Second option, which, in case you have maybe more complicated AI models, maybe you need more horsepower, maybe you need an actual neural decision processor to be able to run those models. You could potentially use our RA2 as kind of the host processor, and then use this neural decision processor to actually just do the running of the AI models, and then you can do the rest of the stuff in the microcontroller with a similar setup, right? So then the data would kind of go through the RA2, then kind of pass on to the neural decision processors to actually output some data and send it back to the RA2. And then from there, you could potentially, again, output that data, whether that's to a screen or via wireless to a phone or tablet or whatever the case is. But yeah, I mean, these are kind of the 2 options. Feel free to kind of use these ideas. If you guys have better ideas, feel free. We want to see how you guys incorporate machine learning into our microcontrollers. So we're really excited about this. So Brad, are you kind of ready were you able to?
Yeah.
Okay, awesome. So we'll pass it on back to Brad for him to finish his demo, and then we'll go to Q&A at the end. So let me stop sharing.
So actually, it's going to be real quick. So yeah, I think I actually just needed to power cycle it. So as you can see, we're just updating the values. So there's not much to show here. Let me see if I can, a cup of coffee now, it's pretty cold, but actually get a little bit of change there. So you can change the duration. So the sensor, it's like we mentioned earlier, it stabilizes within about 3 seconds. But you can continuously read the data. So after you get a stimulus input, it'll take about 3 seconds for you to actually see that kind of stabilize over time. But the temperature values are always coming out. So, to the point here, right, you can use these sensors to quickly get the temperature and humidity relative and easily connect it up with our fast prototyping board with just a few function calls. Okay, so let me stop, Carlos, and you can take over.
All right. So yeah, I mean, again, guys, Quick Connect platform super useful if you guys want to put something together quickly. As you saw, it didn't really take too much time for Brad to kind of actually get some data out of the sensors. And from a hardware perspective, very easy connection. PMOD connector, you plug it in, power the board, and you're pretty much ready to go. And then there's a little bit of work from the software side of things, but definitely we try to help you guys so that you don't have to go into the low level stuff, and you can just really focus on the actual applications that you guys can really get something up quickly rather than taking forever on the low level stuff. Cool. So last slide here again, Q&A. So I guess, Katara, I don't know if there were any kind of questions in the chat for us to answer.
Thank you so much, Carlos and Brad, for this excellent presentation and going over, your platform and all the amazing capabilities that it provides. I hope, we get interest from the community to try it in the important, weather challenge. So thank you again. Yeah, we have some questions. So let me read the first one from Bokar. The question is this application is applicable to IoT or all applications?
So I'm not sure what exactly he means by that, but
I think maybe the question is whether your platform is applicable to IoT, or it can also basically cover other application domains outside of IoT. Maybe we can get some more clarifications from the person.
So, I mean, again, the sensors that we have available with like our Quick Connect platforms, I mean, they pretty much range, you know, I think there was a slide somewhere in here where we kind of show all the different sensors. So our kind of Quick Connect platforms, along with our mic controls, really can go into a lot of applications. As Renesas, we've gone into industrial applications, home IoT, white goods, you know, like really the sky is the limit, right? At the end of the day, it's a general purpose microcontroller. So it's really wide on the applications that we can go into.
Thank you, Carlos. The second question is, how about IoT data moving across ML platforms where we can do some analysis and dashboard them?
Okay, so where we can do some analysis.
I think probably the question is
maybe they can elaborate a little more. Sorry if I'm not.
Well, so let me jump in as well. So yeah, sure. We do have, you know, as part of AWS and Azure, if you're using the RTOS, a lot of the function calls to talk to those particular cloud bases are already available inside. So maybe not so much on the RA2E2 because this is a little bit smaller, but some of our other microcontrollers with a little bit more processing capability do have the ability to basically encapsulate data, send it by MQTT, or you can send it over Wi-Fi. Potentially, you could use the RA2E2 with like our Wi-Fi device, which has basically the ability to do HTTP and MQTT on board, and then also could connect to AWS. So yes, we do have the ability to basically send this data up to the cloud if you needed to do some additional computation and kind of dashboarding of that data that you're reading.
Okay, yeah. Yeah, and I think I did talk a little bit about that as well.
The other question is about how many onboard microphones are available on the RA2E2 board.
We don't have any microphones on board, but that's one of the options that you guys could potentially put one microphone in a PMONT board and then connect it that way. That wouldn't be supported by the by a Quick Connect platform, so you would have to start from somewhat scratch. But that is a possibility. We do have that connector available.
Thank you. And then another question is how many of the self-piezo condensers can I connect to? I can connect to our RA2E2 board.
Brad, do you want to take that one?
I don't have a number offhand. I mean, we can definitely follow up with you. I think it really just depends on number of I/O that we have available on the particular package or the device. So we have a couple different variants and a couple different package sizes. So really depends kind of on which one you're using versus how many available pins there are available.
And then we also have and I don't know if this would apply for this one, but we have the ability to also daisy chain some of like the sensors, right? If you're using like an I2C interface, you could potentially use the same interface to daisy chain different sensors.
Is there a limit? You know, what's the limit on the sensors that you can support?
For the digital sensors, it's really just dependent on, like the I2C, as Carlos mentioned, it's really just dependent on making sure you have enough electrically it's correct. We've daisy chained actually on this one more than 3 at a time. So we've, I've actually written code as well that can do basically 3 to 4 at a time. So you can definitely get quite a few. And then we have multiple ports. So you can also basically use an additional I2C port or to actually get more data out. So you can get quite a few, even for a small package like this, you get quite a few sensors on board.
Thank you. One more question in terms of the modeling piece. Maybe you might have covered it in your presentation. I missed. What's the limit on the model size that you can basically store in this microcontroller?
The actual flash that we have available on the microcontroller is up to 64 kilobytes. I've seen models, that are obviously much bigger than that. But I think with 64 model, you should be able to do things, like the creating a model for detecting rain, for example, with these two type of sensors. I think it shouldn't be that big of a model. But if you wanted to, you could also potentially add external flash. That's always, we do have SPI interface to connect external flash if that's something that you might want to do. And then if you really want the flash to be all integrated into the microcontroller, we do have other microcontrollers that are like the RA4s, RA6, they have bigger flash memory. So that's also a possibility.
And do you think, like, if you do these external flash integration, will there be any, like, some a lot of introduce additional delays if once you do the deployment or live scoring of the model?
Not sure, to be honest. I don't know if I have the technical background to answer that question. We can take it offline. Yeah, that's one of the questions we can take offline and get back to you on.
Okay, thank you. We also have another question from the audience, from Nabil. The question is, what would be missing if we want to build the smart weather station using the tinyML kit available on the market?
The tinyML kit. So I'm guessing, are they talking about the sentient tinyML board? Is that?
I'm not sure, Nabil, if you could maybe clarify the name of the tinyML kit that you're referring to. The EDX one.
EX1. Well, I'm not familiar with that EDX1. I'm familiar with the sentient one, and that's kind of one of the options that I was showing. That second option where you have a external neural network or neural processor. So that would be one possibility where you use the RA2E2 as your core microcontroller, and then you could use the tinyML kit from Sentient. Maybe you might be able to do something similar here. I'm not sure. Again, I'm not super familiar with this board. I'm seeing the link here you sent. But yeah, I think that's something that you would probably need to figure out. I'm not completely familiar with this board.
Okay. Thank you, Carlos. Let me see if we have any more questions. Yeah, there is one more question.
Yeah, go ahead.
Sorry. What is the Synergy development platform not available? Why is the Synergy development platform not available for the RA series?
Brad, you probably have a little more history there. I'll let you.
Sure. Yeah. So the Synergy platform, right, it's for our Synergy product line. It's really fully featured, kind of geared for those devices. RA is kind of it covers a wider range of, so not only in terms of hardware, so we have more RA devices that have been rolled out as part of the RA family. We also have more software that's been built in. One other thing we did was that we actually re-engineered quite a few of the drivers themselves to be much leaner. So like for a small device like the RA2E2, the driver that we have with the FSP is a little bit leaner so that it actually can take up less code space and be more efficient on a small device that's really resource constrained. So, they're very similar, RA FSP and the Synergy development platform for the Synergy devices. Kind of the Synergy ones are kind of separated to those particular MCUs that they support. And then for these newer MCUs that are coming out, these are all FSP based. If you've used both, the look and feel is going to be very similar. So if you needed to move from one to the other, it should be pretty straightforward for you to do.
Thank you very much, Brad. So I guess we're at the top of the hour. So I would like to take again the opportunity to thank our speakers for their excellent presentation and the demo also. I hope you guys give this platform a chance. It has a lot of potential. And basically, create a great solution using tinyML for this important challenge. Thank you again, Carlos and Brad, for your valuable time and sharing with us today.
Thanks, everyone. And if you guys do have more questions that maybe we didn't completely answer today, I did include that link in the presentation, for you guys to possibly submit a ticket, or you can also try our frequently asked questions or our forum that we have on our website. So thank you.
Thank you very much. And last but not least, I want to thank again our tinyML strategic partners. So our executive strategic partners, Arm AI, and Powering tinyML Innovation, and Arm AI has also an excellent series of virtual tech talks. You can find out more through this link. Edge Impulse, the leading development platform for Edge ML. Qualcomm AI Research, they're advancing AI research to make efficient AI ubiquitous. Sentient, to accelerate the edge compute and making edge AI a reality. Our Platinum strategic partners, Deep Light for fastest video analytics solutions on ARM CPUs. Clayca Tech, a global IoT solution. And Reality AI, giving high value or safety critical use cases. And Renesas, enabling the next generation of AI-powered solutions that will revolutionize every industry sector. Thank you again, the Renaissance speakers today. Sony Semiconductor Solutions Corporation, our gold strategic partners. Thank you to our gold strategic partners, Analog Devices, witnessing potential made possible at analog.com. PhotoHub, who are making over-the-air firmware and ML models updates simple and accessible. Microsoft and NXP, accelerating the breakthroughs that advance our world. And Seed Studio, deploying tinyML into the real-world plug-and-play machine learning. And SensiML with their analytics toolkit suite for AutoML, team collaboration, vision control, and model management. ST Microelectronics, providing extensive solutions to make tiny machine learning easy. And Synaptics, engineering potential experiences. SynSense, building sensing and interfacing hardware for ultra-low power. And also many thanks to our silver strategic partners, Ion Devices, EMSA, Greenwaves, Gravity Inc., Imagimob, Itimix, Nota AI, OctoML, Prophecy, Kixo, Rixan, SAP, Silicon Labs, Stream Analyze, TDK, and IBM. Thank you all for attending today's webinar, and we look forward to your participation in future events. And thank you again to our speakers.